It is absolutely clear that humans do better on a diurnal schedule than a nocturnal schedule.
Andrew Huberman studied how sleep works, the different parts of it, and how it helps us learn and control our feelings. His work helps us understand sleep better. We're exploring a new, exciting place. His nuanced and comprehensive explanation of the difference between how slow-wave sleep and rapid eye movement sleep stages not only untangles these enigmatic processes, but also unveils their significant consequences on our psychological well-being and cognitive potential. The exploration of the sleeping stages ignites a newfound respect for sleep. It triggers the realization that sleep isn't just about the total hours of unconsciousness or restfulness. Instead, it's an intricately balanced symphony of different phases, each characterized by distinct features, and each contributing to our mental health in unique ways. So, good sleep is about having the right balance of slow wave and REM sleep, and it's not just about how long you sleep.
People that are strictly nocturnal do far worse on immune function, on metabolic function, etc., than people who are diurnal, who are awake during the daytime.
An aspect of Huberman's discussion that leaves a deep imprint on the listener is his introduction of the concept of unlearning emotional events during sleep. It's a profound exploration of the idea that our brains, while we sleep, have the ability to engage in an active process of managing, and even modifying our reactions to emotional stimuli. This concept can prove to be a revolutionary milestone for individuals grappling with psychological challenges like trauma or anxiety. It's a strong testament that sleep isn't just a passive period of physical rest, but it's an active, vibrant, and restorative mental process, instrumental in nurturing resilience and promoting healing.
The temperature oscillation is the effector of the circadian clock. So every cell in our body has a 24-hour rhythm that's dictated by genes like clock, purr, BMAL, that create 24-hour oscillations in gene expression, etc., in every cell of our body. But what aligns those is a signal from the master circadian clock, which sits right above the roof of the mouth, called the suprachiasmatic nucleus. And that clock synchronizes all the clocks of the body to this general temperature rhythm by way of controlling systemic temperature, which makes perfect sense. If you want to create a general oscillation in all the tissues and organs of the body, use temperature. And so that work on temperature, if people want to explore it further, was Joe Takahashi, who was at Northwestern, now at UT Southwestern in Dallas. And it is absolutely clear that humans do better on a diurnal schedule, sorry Lex, than a nocturnal schedule. Because you could say, well, provided I sleep and push adenosine back downhill, which is what happens when we sleep, adenosine is then reduced. And provided I am on more or less a 24-hour schedule, why should it matter that I'm awake when the sun's out and I'm asleep when the sun is down? But it turns out that if you look at health metrics, people that are strictly nocturnal do far worse on immune function, on metabolic function, etc., than people who are diurnal, who are awake during the daytime. And animals that are nocturnal, it's the opposite. And animals that are so-called crepuscular, which tend to be active at dawn and at dusk. Mm-hmm. This is a beautiful system. I won't go down that rabbit hole, but these are animals whose visual systems operate best. They tend to be predators like mountain lions. They have optimized their waking times for the times when the animals they eat can't see well in those light conditions. But given the rod cone ratios in their eyes, the mountain lion is picking up. It's like when you see special forces and they're looking through night vision goggles and they have a clear advantage, right? They're seeing in the dark. That's basically what it's like to be a mountain lion as opposed to a bunny rabbit.
The detailed exploration by Andrew Huberman of the possibility of learning during our sleeping hours presents an intriguing prospect for enhancing our cognitive potential. His in-depth explanation paints a vivid picture of how, even while our bodies rest and rejuvenate during sleep, our minds are constantly active, relentlessly working and processing information, which exposes an interesting paradox. Despite our bodies being in a state of physical inactivity during sleep, our brains remain in an active state of engagement. It raises a curious question. How can we harness this newfound knowledge to amplify our abilities in learning, memory foundation, and consolidation processes? Although this field is relatively nascent, necessitating further exploration and rigorous research, the prospect of uncovering innovative methods of enhancing cognitive abilities during sleep appears to be highly promising.
There had to have been a time in which humans being awake and active at night as opposed to during the day led to higher levels of lethality and probably particular in kids. You imagine kids running around in the dark and getting where there are a lot of animals that can see really well under those conditions and humans can't. And this would be all pre-electricity. Even if you're carrying a torch, I mean, the range of illumination on a torch is nothing compared to what a nighttime predator like a large cat or something can do. I mean, they can see everything they need to in order to eat us, and not the other way around. Yeah, discovered in the 50s at the University of Chicago. It's intense brain activity, high levels of metabolic activity, dreams in which people report a lot of the theory of mind. We were talking about Simon Baron-Cohen. Theory of mind was actually something that he developed for the diagnosis of autism. If you take most kids of age 5, 6, 7, you put them in front of a TV screen in a laboratory and you have them watch a video where a kid is playing with a ball or a doll, and then the kid puts it into a drawer, shuts the drawer and walks away, and another kid comes in and you ask the child who's observing this little movie, you say, what does this second child think? And a typical kid would say, they want to play and they don't know where the ball or doll is, or they're upset or they're sad, they want the doll. Autistic children tend to say, the doll's in the drawer, the toy's in the drawer. They tend to fixate. They can't get in on the event. They can't get into the mind they don't have a theory of mind. Dreams in REM have a heavy theory of mind component. People are after me, trying to get me. You can assign motive to other people. I'm afraid, but it's because there's an expectation. That doesn't tend to happen in slow wave sleep dreams. Now, all this, of course, is by waking people up and asking them what they were dreaming about, which from a standpoint of a AI guy or a machine learning guy or a neuroscientist, kind of like, but it's the best we've got. But brain imaging in waking states while people view a movie, and then brain imaging while people are sleeping, supports the idea that that's basically what's going on. So REM sleep is amazing, and your body and brain are smart. They will know that your main goal is to recover so you can keep going, so you can keep firing neuromuscular contractions and you can keep running.
In his pursuit of unraveling the mysteries of sleep, Huberman delves into the complexities of slow-wave sleep and rapid eye movement sleep with commendable clarity and depth. To most people, sleep phases are just ambiguous constructs, having a vague association with dreams and the depth of our slumber. However, this thought-provoking episode breaks the surface, unmasking the intricate web of cerebral activities during each sleep stage. It uncloaks the fact that slow-wave sleep and REM sleep are not just different points in the sleep cycle, but they play distinctive, critical roles, each with far-reaching implications for our cognitive health and our overall wellness. It reveals that these stages of sleep are not just about dreaming or achieving deep rest, but they're actually about crucial periods of cerebral activity, each stage performing unique functions.
I agree that one can have a dysregulated sleep schedule and still be a happy person and productive. I mean, much of my life, I've pulled all-nighters and slept weird schedules. I think many people can probably relate to going to sleep, waking up 4 hours later, being up for an hour or two on your computer, then going back to sleep and getting amazing sleep the next day functioning. Yeah. I think it's important that people have highlighted the importance of sleep and getting enough rest. I do think it's gone too far, and now I'm editorializing a little bit, but I think that we've created this anxiety about sleep that if we don't sleep enough, we're going to get dementia. If we don't get sleep, then the reproductive axis is going to completely crash. There's a lot of evidence to the contrary, and as well, just based on personal experience and based on the fact that, sure, that it may be that a solid 8 hours with no interruptions in there, or 9 or 10, could do great benefit, but you can do really well if you do what you say, which is you wake up, you don't want to start stressing about it, creating this meta stress about sleep. Being happy, it is actually one of the most powerful things that you can do, not allowing yourself to go down that rabbit hole of stress, for the following reason. A lot of our fatigue is not due just to the buildup of adenosine or time of day, the circadian thing we were talking about earlier. An additional factor is that effort is related to the release of epinephrine, of adrenaline in our brain and body. At some point, those levels get so high that we get stressed mentally, we get stressed physically, and we want to give up. There are good data published in Cell showing that signal, the epinephrine signal, eventually accumulates and there's a quit point. Dopamine, the molecule of pursuit and reward and feeling good, resets our ability to be in effort. In fact, a lot of people don't know this, but dopamine is actually what epinephrine is made from. If you look at the biochemical cascade, it starts with tyrosine, which is rich in found in red meats and things of that sort. And tyrosine is eventually converted through things like L-DOPA into dopamine. Dopamine is made into epinephrine. So, I mean, this sounds kind of new agey, but happiness, joy, and pleasure in what you're doing creates a chemical milieu that provides more of the chemicals that allow for effort. And there's nothing new agey about that. It's in every biochemistry textbook. Yeah. It's in every decent neuroscience textbook. They just don't talk about the happiness part. They just talk about the dopamine part. So I think that limiting your stress and at least recognizing, okay, if you're pulling an all-nighter or you're somehow on messed up sleep, that there is going to be a point in that 24-hour cycle where your brain is not trustworthy, where your mental state is not worth placing too much weight on because you are near that temperature minimum. And near that temperature minimum, which correlates to that about 2 hours before you would normally wake up, the brain is hobbling along. And anything you feel or think at that time should not be given too much value. But if you can trick yourself into thinking that's the pleasure point, you afford yourself a huge advantage. So it's not that just getting more sleep allows you to perform better. Consistently getting about the same amount of sleep is better for performance than just getting more.